In this lecture, we're going to look at the second big piece of observational evidence for the Big Bang, primordial nucleosynthesis. So the second prediction the Big Bang makes is that if we use what we know about nuclear physics, we can predict what elements were created during the first thousands of years after the Big Bang, and we can predict what proportion they will be made in. If that matches the proportions that we can infer from observations today, then we're going to get more support for the Big Bang model. Here's a graph of those predictions. This is on the top, time after the Big Bang, so 10 seconds, 100 seconds, 1,000 seconds, 10,000 seconds. And along the bottom is the temperature of the universe at those times. So 10 seconds after the Big Bang, you're at about 3 billion degrees Kelvin. Now, these hot temperatures, you've got protons and neutrons completely dissociated. The temperature is so hot that they do not form into nuclei. And as you cool down, they're going to start binding with each other to form hydrogen, helium, deuterium, helium-3, and a few other light isotopes in very small abundances. So let's go briefly over how this works. Initially, the universe is a plasma, a cosmic soup of charged particles. So you've got electrons, neutrons, and protons. As the universe cools, about 300,000 years later, that's when the temperature cools below about 6,000 degrees Kelvin, and electrons can bind to hydrogen and helium. The protons and neutrons have already been able to bind to form nuclei, and you get hydrogen, helium, what we would call ordinary matter. So you get a bunch of mostly hydrogen and helium atoms floating about. The universe is now not a plasma anymore. It is a gas of mostly hydrogen and helium. So applying our laws of physics, we get the following prediction: that immediately after the universe cools below around 6,000 degrees Kelvin, so about 300,000 years after the Big Bang, the universe should be composed of a gas of about 75% hydrogen, 25% helium, 0.01% deuterium, and trace amounts of lithium and beryllium. So how do we check this? How do we observe the amounts of different elements in the early universe? Well, we look far away, which means looking back in time. Here we are looking back in time, and if we look at the, say, Hubble Deep Field and Hubble Ultra Deep Field photos, we're looking back in time, so far back in time that we are seeing the first galaxies that were created after the Big Bang. That means the gas that the stars in these galaxies are composed of should have the proportions predicted by the Big Bang. And indeed, that is exactly what we find. So by observing light from the most distant objects and inferring their composition from their spectra, we are able to confirm the second prediction of the Big Bang model.